All right, let's get into it. Today, we're going to take what looks like a simple quiz and basically turn it into this powerful toolkit, a way to really understand all the numbers that shape our world. I mean, think about it. From news headlines to just our daily decisions, data is literally everywhere. And by the end of this, you're going to feel so much more confident navigating all of it. Biased data, tricky stats, confusing odds. Does any of that sound familiar? Look, if you've ever felt just a little bit lost trying to make sense of a statistic you saw, or trying to figure out the real odds of something happening, you're not alone. Not at all. It can feel like you're trying to read a totally different language, right? But what if I told you the core ideas, they're actually things we can all get our heads around?
So, here's the game plan. We'll kick things off with the rules of chance. Then, we'll get into making sense of numbers with some basic stats. After that, and this is a big one, we'll learn how to read between the lines of data. And finally, we'll wrap it all up into your own personal data toolkit.
Okay, Section 1, the rules of chance. We're starting right at the beginning here with probability. This is all about the mathematics of chance, kind of like the art of predicting the future, one outcome at a time.
So, at its heart, probability has this super simple formula. Just think about rolling a regular six-sided die. You've got six possible outcomes, right? But only one of those is the number 5. So the probability of rolling a 5 is just one favorable outcome out of 6 total outcomes. Simple as that, a 1 in 6 shot. But what about when events are independent? What does that even mean? Well, think about it. If you roll a die, the outcome of that first roll has absolutely zero impact on the second one. They're totally separate. These are called independent events. So the chance of rolling an even number, well, that's 3 out of 6, or just 1/2. Now, to find the probability of doing it twice in a row, you just multiply those odds together. So 1/2 times 1/2, that gives us a 1 in 4 chance. And this applies to coin tosses too. It's the classic example, right? Every single flip is a totally fresh start with a 50-50 chance. It doesn't matter if you just got tails 4 times in a row. That fifth flip doesn't owe you a heads. The odds are still 1/2. So if you're wondering what the chance of getting tails 5 times in a row is, you just multiply 1/2 by itself 5 times. And that's how you get that 1 in 32 chance. Okay, but this is where it gets really interesting. What happens when one event does change the odds for the next one? Because not everything is like a coin flip. Sometimes the first thing you do completely changes the game for the second. And that brings us to the classic sock drawer problem. Let's walk through this step by step. So when you first reach in, you've got 18 socks in there, and 6 of them are black. That means your chance of pulling out a black one is 6 out of 18. Easy enough. But here's the key. You don't put it back. So now everything's changed. There are only 17 socks left in the drawer, and 8 of them are still blue. So the probability for your second pull is now 8 out of 17. To get the final odds, we just multiply those two probabilities together, and boom, we get our answer. 8 in 51. All right, let's keep building on this. We're going to shift gears a little bit, from trying to predict the future with probability to describing what's already happened using statistics. This is all about taking that raw data and turning it into some real, understandable insights. So let's start with something we see all the time, percentages. Say 180 students are trying out for a play, but only 15% are going to be chosen. How many actually get a role? Well, you just take that 15%, turn it into its decimal form, that's 0.15, and multiply it by 180. And there you go, simple as that. 27 students get to be in the play. Now, ratios can seem a little abstract sometimes, but they're really just about comparing quantities. So here we've got a 2-to-1 ratio of teachers to students. The easiest way to think about this is in parts. That means there are 11 parts in total, right? 2 plus 9. So we take the whole crowd, 3,520 people, and divide it by 11. That tells us that each part is 320 people. And from there, it's a piece of cake. 2 parts are teachers, so that's 640, and 9 parts are students, which gives us 2,880.
Oh man, we've all been here, right? Staring at our grades, trying to figure out what score we need on the final. So let's look at the logic. For Maria to get an average of 90 across 4 tests, she needs a grand total of 360 points. That's just 90 times 4. We know she already has an 88 average on her first 3 tests, which means she's banked 264 points so far. So what's the difference between the 360 she needs and the 264 she has? It's 96. That's the score she's got to aim for. Okay, now this is where things get really cool, because there are different ways to describe the center of a set of numbers.
The mean is what we usually think of as the average. The median is the number that's smack in the middle once you line them all up. The mode is just the one that shows up the most often. And the range tells you how spread out everything is. And look here, notice how the mean is 9, but the median and the mode are both 8. That difference tells you something. And that brings us to this key idea. The mean, the median, and the mode, they have a collective name, measures of central tendency. It's just a fancy way of saying they each give us a slightly different snapshot of what a typical number in the data looks like. And honestly, knowing which one to pay attention to, that's a huge part of really understanding stats. Okay, now we're getting to the really critical stuff. It's not just about crunching the numbers, it's about interpreting them correctly. And, just as important, spotting when data might be trying to mislead you. This section is all about learning to read between the numbers. So let's talk about relationships in data. You hear about this all the time. A positive correlation is simply when two things tend to move in the same direction. So, for example, the more hours you study, the higher your test score is likely to be. Makes sense, right? And a negative correlation is the opposite, when they move in opposite directions. Think about it. As the temperature goes up, sales of winter coats tend to go down. And this right here, this is so important. For a survey to be valid, the sample, the group of people you ask, has to be representative of the entire population. Let me give you an example. If you want to know what teenagers think about movies, but you only ask the members of the school sci-fi club, your results are going to be totally biased. Why? Because that small group doesn't represent all teenagers. Your sample is skewed, and so your conclusions are just unreliable. You should always be asking, who did they survey here?
All right, time for a little quick-fire round on how we visualize data. I promise you've seen these before. So, which chart uses those overlapping circles to show the relationships between different sets?
You got it! It's the Venn diagram. They are perfect for seeing where things overlap. For instance, if you were tracking students who play sports, those overlapping sections would immediately show you who plays more than one sport. You could just add up the numbers in those overlaps, and you'd know exactly how many multi-sport athletes you have. Okay, next one. Let's say you want to compare the sales figures for 5 different products right next to each other. What's your go-to chart? You know, the one that uses those rectangular bars to show the amounts? That, of course, would be the bar graph. It's so good for comparing different separate categories because you can see in an instant which bar's longer or shorter. It makes those comparisons super quick and intuitive. Wow, we've really covered a lot of ground, huh? From basic odds all the way to some pretty complex interpretation. So let's wrap this all up and pack your new skills into a toolkit that you can actually take with you and use. And here it is. Your toolkit is officially packed. You're not just looking at numbers anymore. You're able to see the story behind them. You can distinguish between different types of events, you can calculate key stats, and maybe most importantly, you can think critically about how data is collected and presented. This is an absolutely fantastic foundation for making sense of the world. So here's the real takeaway. You now have the tools. You have the framework to look at the world just a little bit differently. To not just accept a statistic you see at face value, but to actually be curious about it. To ask, hey, where did that come from? How was it measured? And what story is it really trying to tell? The numbers are out there waiting. So what will you question next?